Hello, friends. This is the AlphaList podcast. I am your host, Toby. The goal of the AlphaList podcast is to empower CTOs with the info and insight they need to make the best decisions for their company. We do this by hosting top thought leaders and picking their brains for insights into technical leadership and tech trends. If you believe in the power of accumulated knowledge to accelerate growth, make sure to subscribe to this podcast. Plus, if you're an experienced CTO, you will love the discussion happening in our Slack space where over 600 CTOs are sharing insights, or visit one of our events. Just go to alphalist.com to apply. Welcome to the AlphaList podcast. I'm your host, Toby, and my guest today is a Dutch hacker who managed to put an entire data warehouse inside a single Python process and halved a few cloud builds along the way. Welcome, DuckDB creator Mark Raasveldt.
Thank you very much for having me.
So, thanks for being here. And I have to be super honest, like I'm a new user to DuckDB and just realized how powerful it is like a few days ago. With my acquisition company, SaaS Group, we actually acquired one company that has like tons of data. I don't know, a few billion of requests per day that they managed to crunch on very large old hardware. And they are right now moving to the cloud. And I said, go for BigQuery, go for it. And the guy who's investigating that all and tries to move it to Greenfield a few days ago mentioned DuckDB. And I just realized, hey, I have a podcast recording scheduled.
Right on time. Right on time. And he actually mentioned that they basically crunched like a few days of data just on a single machine on a MacBook, Parquet files without no issues. So that's a perfect introduction for your solution. That's amazing. Yeah.
So maybe we start a little earlier before we dive deeper into DuckDB and how you came to that idea and build it. Maybe starting with you, Mark. Rewind a little. Like, what's your nerd path? Like, why did you get into computing? Why are you fascinated by it? And why do you do what you do?
Of course. I mean, I can go all the way back. I think so. I got into computing kind of by accident. I got into CS by accident, mostly because I was really into video games growing up, which I guess is a path
typical.
A bunch of people,
yes.
A bunch of people share. And I went into I left high school and I had to pick something to do as one does, like pick something to study. And I saw a study program at the university that was called like game programming or game technology. And that spoke to me because I had been doing computer science also in my high school. They had a computer science class. And I was doing there and I had made some video games there as well. And I was doing like other computer science things. So I thought it was very cool. And then when I arrived at the program, I realized they had tricked me because they called it game programming, but it was really a computer science degree with like a little sort of asterisk that a lot of the practical assignments were related to like making video games instead of like the regular computer science curriculum in which, I mean, I haven't followed this, but I guess you make like more programs sort of thing. But it had a lot of the same curriculum, including database systems and things like that. So I did my bachelor in like computer science with a sort of annotation of programming video games. And then when it came time to do my master's degree, I realized that actually, what I liked so much about the bachelor was not specifically video games, although I liked that as well. It was actually just programming. Like I just liked computers and technology and stuff like that. So I figured I'd just do a regular master's in computer science. And as part of my master's, I followed a database course, and my what then became my supervisor for my master's basically gave a guest lecture. So I was doing my master's at the Utrecht University, and during my my lectures that I was taking as part of that, Hannes Moelijsen he came and gave a presentation about the system he was working on at the time and the research lab, the database architecture group at the CWI, and what they were working on. And I thought that was really cool. And I ended up going there and working together with him. And then I did my master's there. I did my PhD there. Like I just kind of stuck around. And during my PhD, together with Hannes, we together built DuckDB. Like that's kind of the story of how that ended up. I did like a bunch of work on the other database system they had there. And yeah, that's the path of how we ended up building the system together. That was, I think, around 2018, 2019, I want to say. And then that kind of just has been steadily growing. It started out fully as sort of like a research project, but with the intention that people would start using it. They did start using it, and then in the end, we ended up building a company around it, spinning out, and now we're here, and there's tons of people using it, and more each day. It's a very cool trajectory we've had.
But that's super interesting. I mean, from like wanting to, I don't know, build story-heavy games to now building building a database system that's a bit boring.
Well, we try to make DuckDB fun to use, which is, I think, is actually kind of part of why we're successful. So a lot of database systems are, I think, not fun to use. And one of the things that we do try to do is to make it fun to use DuckDB. And that's like, it goes down to some of the little things as well. Like if you start it up on the CLI, you get like some syntax highlighting, and like we try to make data development fun and easy, kind of. So it's part of our motto. Like we try to make it not boring. And for me, it's certainly not boring. I mean, I got really sucked into the database world. Like it's an amazing world, amazing smart people solving really hard problems. Like I'm in love with it. Obviously, I've been into it for a while.
So how often did you go out for a beer with Monty or others then?
I don't think I've met the creator of MariaDB, but at every sort of database conference, database meetup, there's like a crew of people. We all hang out together, and it's maybe not well known outside of the database community, but within the database community, it's certainly well known that database people are a bunch of alcoholics. So there's like every time. I think it may have something to do with like where they're based. So database people have a heavy skew towards Germany and Netherlands, and that like it kind of leans into it. So absolutely.
Can you tell us a bit more about the database community? Like, how is it? Like, I just know the creator of MariaDB, who also accidentally created MySQL back in the days, who's like well known, but who else is in that scene, and how did that develop?
I think the database world, the world I come from is the research world. I think it's very interesting because it's like in a typical research world, there is generally not that much like money to go around, not that much industry interest, right? Because a lot of what research does is kind of orthogonal to, or like it's not orthogonal, it's like kind of more of an early stage. It's not like directly in contact with like solving problems that users are facing. And because the database research world, because it's so applied, there is like a lot of connections between industry and research. Like there's a very sort of tight-knit community where there's database researchers, industry, and there's like a lot of like cross-contamination there, if you will, where a lot of the database researchers, they go work in industry for a while, or maybe they leave altogether to work in industry. There's like database systems that come out of academia that become like the big systems, and also the other way around, right? Like the big systems in industry, they're very heavily researched in academia again. So there's like a lot of sort of collaboration between the two, like the industry and academia. And it's really nice to see, and it's really, really cool. And I think it's one of the reasons, like one of the things that drew me to databases is how it's like so fiercely practical while still being like at the research level, like very interesting, right?
Like the real version of it is that like at conferences you hang out and drink beers.
Yeah.
With like everyone who's in that scene, I guess.
Absolutely, absolutely. Yeah. It's we call it networking, by the way. It's not just hanging out and drinking beers, it's networking.
Networking.
But
Okay.
yes, that's what it comes down to. Yeah. The database community, they are a bunch of alcoholics. So it's always a good time. And it's definitely like it's both academia and like research like side by side at these events.
Cool. What I really admire if I look at your story is the fact that you're like really bootstrapped out of science in a way. Like you did, like started off as a scientific project and then spun it out of university and then like really built a company out of that. And you don't have like huge funding, but you're only like 30 people and you're disrupting a market which is like heavily VC backed or used to be heavily VC backed and very cloud dominated by big players. Like Google is active there. There's like more like let's say older technology like Spark, etc. And you kind of went into that and you disrupted that without a dollar, without a penny, I would say.
Well, we had our research salaries, of course. But
sure. But you managed to do that. Like, can you tell us a bit more about your story and the challenges that you faced on the way when bootstrapping the company straight out of university? And
so I would actually lie if I said it was very difficult. I think we got super lucky, like kind of the pieces fell into place. If you want to develop a database system, I think there's a lot of work that needs to go into it that to be able like to even run your first query, to get like your first user on board. Like there's a lot of stuff that needs to happen. And I think research for like the lab where we were at was a perfect place to do that initial work. Partly because there was a bit of like what we like to call the management vacuum. So in some research labs, there's a sort of very strict oversight of people where they are basically like, you have to write like 2 papers a year and like you have to get like results like this month and then next month you have to get results. A lot of like management going around. The situation we were at was that there was like not much of that sort of like low level management and we could kind of do whatever we wanted. We were kind of in a nice position where I was doing my PhD, but I'd already written up all my papers and like finished my thesis, but I still had like some time left on my contract. So like no one really cared, right? And Hannes had just gotten tenure. And at that point you can do whatever you want, as you know. So we were both in like this position where we could kind of just spend a few years working on something kind of crazy that may not have immediate sort of research benefits while still working as researchers. So I think that worked extremely well. And it tied in very well with actually a lot of the research I was doing. So before what I worked on, before I made DuckDB, me and Hannes together, we worked on basically database systems for data analytics. And there was another system that was developed at the CWI called MonetDB. And we tried to basically get researchers like data scientists, data analysts, data engineers to use that system and try to figure out like, okay, what is the nicest way of interacting with the database system? And we tried different approaches. We tried like user-defined functions within the system. We tried like different integrations. And kind of what we landed on was like kind of the precursor to DuckDB, which we called MonetDB Lite, based on SQLite. Which was this embedded analytical database system. And that's something that a few like of our users, like we got actually some traction. A few people really loved it. They said it solved like tons of their problems. But we ran into like some fundamental limitations of like taking an existing database system that was not built for that and using it as an in-process database system, which is why we eventually, after several years of trying it, decided to build something custom for this scenario. And that worked out very well. And we basically, like, as we were developing, continuously got users and users until we got to the point where people started putting it in production. And they were like, we want to put this in production, but we need to have like some contracts to like get support, things like that, right? And then we went to our university actually first, and we're like, hey, can we do a support contract? And the university was like, yeah, we only take grants, sorry. So we actually convinced some companies, which is the craziest part, to do grants with like basically just giving money for nothing, right? Like a contract that was like, here, university, have money, in exchange you get nothing. And then we had like a little sort of wink, wink, nudge, nudge of like, yeah, we'll help you. And we obviously did, right? but it's like some other companies weren't so cool with it, and that's why we kind of ended up spinning out. Because like when people start telling you like we want to give you money and you can't take it, like at some point like something has to give.
And from your today's perspective, I think you did something that like many bootstrappers actually advise you to, right? Like you start doing consulting somewhere, and then with like 20 hours you do consulting, and the rest of your time you spend on your real product that you want to develop. Like from your today's perspective, how do you think those financial constraints and this constrained development influence the product? Like, is it for good or for worse? Like, how do you see that today?
I think our scope initially when building DuckDB was actually much smaller than what it ended up becoming. So I think that we started off with this idea of like, okay, we can make a in-process analytical database system that will solve some of the problems that data analysts face. Basically, like we set out to make DuckDB's Python package. That was kind of the core idea. And then it has kind of like continuously grown from that. And like people continuously surprise us with use cases. I think that's kind of something that's what was surprising to us initially as well, was that, hey, we can take this like Python package that does like very fast analytics, like, and we can actually just like use that as the backend for our whole data stack, or like replace large parts of it with that. So it's I think we started out with a small scope, and people just kept using it for more, right? Like it was for us also a surprise in many ways.
So you did like product discovery in a way, right? You started early, had early users who told you how they use the product, and then you added more features, etc. Like, do you have to be super careful about which things you add to the system and which things you rather leave out? Like, how do you manage? How's your governance? How does your governance look like?
Yeah, no, absolutely. So our governance, the way the project is run is that we have a foundation, and the foundation, it's like a nonprofit that owns the IP and the trademarks, all the code. It owns the DuckDB name, the domain, all that stuff. And our company, it's basically works and contributes all that back to the foundation. So the project is like kind of safeguarded in that foundation. As for like the sort of the code wise of that, we try to keep the core of DuckDB kind of lean, and there's quite some core set of principles that we have of what should and should not go into the core system. And we kind of try to mimic like other successful projects like Python, which, fun story, by the way, Python comes from the same research institute that we come from, also from the CWI Amsterdam, where the core is kind of this lean thing, and there are extensions and plugins that you can install to do other things. Precisely because there is this sort of like, we realize there's this sort of like large landscape of applications for the system that are quite like divergent in some ways. Like they go into completely different directions and territories, and they don't necessarily all need to have the same sort of code footprint. In fact, for some deployments, having like a small code footprint is very important. So we have our WebAssembly deployments, maybe you've seen it, where DuckDB can run in your browser. It's very critical that that is as small as possible, because we send the whole database system to your browser as like a JavaScript package, right? So it needs to be small. But we're very strict about what goes into the core. And then we try to encourage people to build extensions. And we also have a framework for pluggable extensions. Like we have a community extensions repository where people can make their own extensions. And we have our own that we call the core extensions that we maintain as a team. And then basically anything that we think shouldn't go into the core system goes into those extensions.
So there's no commercial software that you sell, right? Like you don't sell software, you don't sell any modules. It's all open, it's all for free, and you just sell support.
Absolutely, yeah. So we originally, when we started off like our company, we thought of like different ways to monetize it. And one of the things we did think about was, okay, we can make commercial extensions. And we have talked to some customers about it, but it turns out most of our customers actually don't want things to be commercial, like to be private, because if it's open source and other people start using it, we have to maintain it. Whereas if it's private, like we don't, right? Like if they stop paying us, for example, then we will just leave their sort of private extensions. They can keep using them, obviously, but they will basically have to keep on contracting with us in order for us to maintain it. Whereas if it's in the open source, we kind of have some obligation to start to keep it up to date and keep maintaining it. So I think it's something that we learn is that there is a lot of sort of like both the people that our customers that pay us to develop the software, and for us and the project, making everything open source has worked very well because of that. Like they want it to be open because then it gets to the open, it becomes maintained. Other people do like testing of it, like it becomes more stable that way. You get a lot of the benefits of open source. And we want it to be open because anything that we make, if it goes into the open source, it grows the project. And from like, obviously we want to grow the project just because we're excited about it, right? We like the project, but also from a business point of view, we want to grow the project because the project is like kind of the entry point for customers. Like people start using DuckDB for free, they get the open source version, and then they talk to us, right? So the more people use DuckDB, the more people that want to talk to us, that want to contract with us, that want support contracts. That's kind of like the way we see that sort of the pipeline. And that's why we want to, among others, grow the project as much as possible.
Like to me, like many of the things you say and the success you have with your database, like kind of rings a bell that there are like crazy war stories where someone approached you to, I don't know, buy your whole company or back you with $1 trillion or something like that. Is there anything where you thought like, whoa, this is too crazy? Like XYZ wrote me and like we have to turn down the offer, but it sounds so nice.
So it's interesting because we had a long round when we started the company of talking to venture capitalists, and we initially thought we were going to take venture capitalist funding, but we ended up not taking it after a lot of consideration. We talked to many venture capitalists, like all of the big ones. And I think the reason was precisely because we thought that taking venture capital, it would lead to this moment where we would have to choose between like paying them back in a way and the project. And we kind of wanted to avoid that. We want to make sure that we can always keep the project like in a good, healthy state. But we actually, there's one thing that we have done that we think is very interesting. There is another company, which is our kind of like partnership / partially a daughter company called MotherDuck. Maybe you've heard of them. And they have taken VC money. So that was actually one of the ideas that came from one of the professors at our research institute who was advising us, who was in the past made companies, who in the past has made several startups and has experience in this domain. And he thought, okay, what if you make a company that is like not VC funded, that maintains the core system, but there are you like kind of work together with other companies that build like sort of like we call it like a verticals out of the core. And the idea is that DuckDB is very like general purpose. You can use it for many different verticals, right? You can obviously build a data warehouse with it, but maybe you can also embed it in like a car or something, right? Like there's different verticals you can go into. And the idea is that we maintain the core product, and then there's other companies that we work together with that pay us, and partially also in shares, to develop that vertical. And then we work very closely together with them to make sure it's a success. And then that means the core sort of product, the project itself is isolated because we as a company have not taken VC money. We're kind of independent, but there's still this sort of hyperscaler stuff that can happen on the fringes. So MotherDuck, they make a service product around DuckDB, but like DuckDB as a service, where they do the whole like, okay, let's build a product around people that want to use DuckDB but don't want to necessarily manage stuff themselves, right? Like sort of the BigQuery of DuckDB, if you will, where you just hand someone your credit card and they will take care of the complexity for you. And they're building that, and that's great. They are like excellent at that. They are great at the like. They do all the hard stuff of like, okay, we need to get like the Kubernetes deployments, right? They need to like build a service out there. They need to do all the sort of like, oh, we're actually managing your data, so we have to get like all the nice like certificates of like, oh, we're like compliant to X, Y, and Z and stuff. They do that, and they do that very well. And then we work together, and we maintain the core. So it's
you can do the cool stuff in a nutshell.
For me, I think that is the cool stuff. But everyone thinks different things are the cool stuff. So I'm sure they also have a great like the stuff they're doing is also very cool, by the way. So I don't want to like diminish that. But we can focus on the core. Yes,
quite cool. But coming a bit more to the core, actually, like your concept is basically SQLite. For data analysts, right? Like in a nutshell, and slightly inspired by that potentially as well. And then like your use case is typically like slow running queries for analytics that instead of, I don't know, spinning up a Spark cluster, your customers typically have, or most users out there have too little data to spin up a Spark cluster in reality.
Absolutely,
and that you basically just offer a single core or multi-core single machine software that people can just use on the command line on their like machine with a few gigabytes, a few hundred gigabytes of RAM potentially, and a very, very, very efficient and fast CPU to just analyze, I don't know, a petabyte or what.
Something small, right? So I think one of the sort of realizations that I think it has been made is that like computers have been getting very, very good. Like like the laptop I'm talking to you on right now, it has like 16 cores, 64 gigs of RAM, right? It has like a 2 terabyte disk. Like these are big numbers. And if you look back to where this whole like the Spark thing, which comes from MapReduce, right? Like the Hadoop, all that, like
Hadoop,
the distributed computing, like when that really started was like the early 2000s. And back then you didn't have 64 gigs of memory. You had maybe 64 megabytes or maybe a bit more, but not that much more. So the sort of the realization was that computers have basically gotten better much faster than most data sets have grown. And the reason is also because most data sets are kind of constrained in size. Like if you think about the amount of people on the planet, right? It's growing, but not that fast. It's kind of like the growth is slowing down, right? And a lot of interesting data, at least, it comes in part from humans, right? Like humans make most interesting data sets. And that could be customers or like people typing on a keyboard. And there's only so many people that can type on so many keyboards. Obviously, if you add in like machine generated data, you can go infinite, like you can get as much data as you want, but often that's lower value, less interesting data. So when you look at only the high value interesting data, the amount of data has been growing like this, right? Like it's been going like this. But the speed of computing has been going like this, like very, very steeply. So things that maybe you needed a cluster of computers for in 2003, you can do on your laptop in 2025, right? Like there's this sort of like this intersection point, which we call the data singularity, where 99% of all data problems can be solved on a single computer. And that has been like ever increasing. And so there's this sort of like this increase. And I think that's also in part because of computers and also because of software. Like a lot of software for analysis has been kind of suboptimal and not really state of the art. So there's like very cool algorithms that have been kind of implemented in the database research world, and they have found their way into like basically like the commercial sort of high performance offerings, right? Like Snowflake has an excellent query engine, it's very fast. BigQuery, excellent query engine, very fast. But sort of the off-the-shelf, I run my data thing that is open source that you can run yourself has always been Spark, and Spark is just not very fast on a single node, right? Like the whole selling point of Spark is that it can scale up. And kind of like where DuckDB now sits is that we can process up to like several terabytes of data on a single computer. And it turns out that's more than most people have in terms of data. and especially more than most people have in terms of hot data, right? Or like the working sets, we call it, which is the data they're actually looking at, right?
Which is typically like a day of data or something that you crunch. And
exactly. Yeah, because you may have a lot of historic data, but if all your queries involve only like the last week, then that's the sort of data set size that matters. Like you may have a petabyte of historic data because it goes back 30 years, but then your last week may only be like a few terabytes, and then again it goes back to fitting on a single machine.
Yeah, super interesting. And are you like, I don't know, constrained on data formats? And you mentioned you use Parquet, for example, to store your data typically. So that's like the standard storage engine, I guess. But you're still able to also analyze large CSVs, etc., right? Like
for sure, yeah.
Using your plugin infrastructure, I guess.
Absolutely, yeah. And we have our own set of data formats. I think like one of the core things we're trying to do is to make analytics as easy as possible, and part of that, of course, means working with whatever data sets you have, right? Like as a user, you can't often control what data you need to read because someone else gives you a CSV file, someone else gives you a JSON file, right? So we are not like purists in that regard. Like we're happy to read a CSV file for you as well. And I think that kind of comes down to also, like you mentioned before, the SQLite for analytics. I think there's a bit like we try to be the SQLite for analytics in the sense that we're easy to use, easy to deploy, and things like that. But there's, I think, one big difference between analytical workloads and transactional workloads, which is what SQLite is optimized for, which is that analytical workloads are generally much more varied, right? Like you get a bunch of data from somewhere, like a government website, like someone else decided to gather some CSV files or like dump a bunch of Parquet files to S3, or like there's a lot more variety in what you're reading, and we try to accommodate for all of that as well.
And your data storage engine is in a way like immutable, so you only add new things, you only add schema changes through additional data, right? Like you don't change the data in like itself.
Yeah, so I think what you're talking about is the lakehouse technology that we have, which is Duck Lake.
Yeah.
And indeed, for Duck Lake, we have different ways of storing data. One of them is our own file format, and the other one is Duck Lake, and we can of course also write data to CSV files, JSON files, etc. But one of our more recent additions is the lakehouse technology, Duck Lake, and how that works is effectively you have in S3 bucket or like a blob store, right? Some file system where you want to store data. And that file system is constrained in the sense that you can generally only write new files or delete files. That's a very common sort of use case nowadays. And effectively, what we have done is we have built a database system, like a sort of classical database system that you're used to if you have run, say, Postgres, where you can create tables, insert data, run deletes, updates, over that sort of abstraction by having a bunch of Parquet files sitting there, together with a metadata store that can sit in another database system, like, for example, Postgres, or also our own storage format that I just mentioned, because we also have our own storage format, which is similar to SQLite in a way.
You have that own format to keep it simple, or?
We have our own format because there are just like our own storage format. It's a single file storage format similar to SQLite. However, it's optimized for analytical use cases. So data is stored in a columnar way. There is data compression, and we support basically the multi-table sort of thing. So when we started off creating DuckDB, there was already Parquet, right? That already existed, although it was way less popular than it is now. I think
that was created by Twitter, right? As far as I remember, like by some Twitter engineer.
I'm not sure. It could have been
somewhere in that Hadoop ecosystem.
Yeah,
I remember.
It comes from the Hadoop ecosystem. I'm not sure which companies exactly. I think the original sort of work on Parquet comes from Dremel, like from Google. They had like Dremel, and then like that turned into like an open format. Parquet has been there for a while, but it was not very popular for a long time. I think we, together with others, kind of popularized it by accepting it as a standard and making it easy to work with. But that already existed. The thing is with Parquet is that it is this sort of immutable, write data once and then never read it again sort of thing. So our own format, it's a bit different. So Parquet, what we call that is a table format, and because it stores a single table. And our format is a database format, which means it can store multiple tables, but also things like views or functions or types, right? Schemas, like basically a full database in a single file.
Okay, understood. And generally, like your typical users are like, is basically everyone, right? Like almost everyone out there, like apart from Google, who potentially have more hot data to crunch it with your solution. But typical customers, I guess, have like less than 1 terabyte of data, and typical queries scan like 100 megabytes or something like that, right? Like,
yeah.
And how do you feel that like the world is the world out there that most people also are facing, the reality out there is the story that people are told is kind of bloated. Like, I mean, basically like Google makes you believe that you just need BigQuery and everyone has a BigQuery use case. Like, how many people really have a BigQuery use case from your perspective?
I think it is extremely few. Like, I think it's, I mean, Google themselves have published these numbers, by the way. This is not my data. But I think something like 99% of queries run on BigQuery operate on less than 300 gigabytes of data. So that is once you start going into like what workloads actually need BigQuery, it's from their own workloads, right? So that's already skewed towards people that have like gotten BigQuery because they feel they need it. From their own workloads, it's already like marginal. It's a fractional amount. And one thing we see a lot of people doing is they may not migrate fully to DuckDB because they may still have that one query that needs BigQuery, but they can still save tons of money by using DuckDB for everything else, right? Like, just because you have BigQuery doesn't mean you need all your analysts that are just running some analytics over like a few gigabytes of Parquet files to also use BigQuery for that. So we have seen a lot of these sort of incremental things where people use DuckDB for like 99% of their workloads to save tons of money. Because again, like your analysts already have a laptop. It's free real estate, right? Like you have a laptop right in front of you. Why not just run the query there instead of going and paying Google to run it?
Yeah, in fact, I heard a fun story that at, I think, SoundCloud, there's a query printed, like a BigQuery printed and like sticking to a wall, framed to a wall, that costed, I think, 600K or something like that on BigQuery. Wow. Or was at least meant to cost that much money because someone accidentally forgot the limit.
Yeah, classic. Yeah, and they'll be happy to run it for you, obviously, because they're charging you. They're making money, right? Like, it's the incentives are a bit misaligned, maybe, let's say.
Is it in fact the case that your stuff just runs faster because it's on a single machine and the overhead of distribution is so big that it actually slows many use cases down instead of accelerating it?
So there's different components. So I think when you compare DuckDB to BigQuery and Snowflake, which are like state-of-the-art, amazing engines in their own rights, I think that's definitely the case, that running things on a single process, a single computer, it just removes all of the sort of communication overhead. You can get a lot of speed up over that. But when you compare against, for example, Spark, a big difference is also that DuckDB does use these state-of-the-art query processing technologies that make it much faster just innately as well. So there's two sides of this. When you compare it to BigQuery and Snowflake, absolutely less communication overhead. Like, we don't have to spin up a Kubernetes like instance to like get like a worker to coordinate and communicate and like send over data. Like, right, if it's all there, it's going to be much faster. Oftentimes instant, right? Like, sometimes the whole bottleneck is this coordination, especially if your data sets are small. So absolutely, it saves a lot of time.
Okay, and where are the limits of your solution? Like, when do you touch like too much of the sky?
When do you need to actually use BigQuery or Spark? Yeah, I mean, that's a great question. I think these use cases absolutely still exist, but they're very rare. So it's hard to put an exact number on it, but it's generally up in like the multi-terabyte range. So if you go to like AWS or like your favorite cloud hosting provider, they make single node boxes very, very big nowadays. So you have like, you can rent a computer that has like several terabytes of RAM. It has like 400 cores, right? Like it has a ton of CPU power, and that can crunch through like multi-terabytes workloads, no problem. Once you get to like the petabyte range of working data, right? Like we talked about this before, your working set is like a petabyte. Like maybe you want to actually run a query over all your historic data and you're gathering multiple terabytes a month. Then you may get into that sort of range where you do need a distributed engine, but it's very rare. And I think that's also like, it's more the exception than the rule, even in organizations that do use this. So there's still a lot of value to using DuckDB for like the 99% of use cases that don't.
And is there one crazy use case, like one crazy war story about a time when one laptop crushed a 50-node cluster or something, like where you were like super surprised that, or a client was super surprised that it ultimately worked out? And
I think I don't have the exact queries, but there are some workloads where we beat BigQuery by quite some amount. As for the laptop, like we recently did my co-founder Hannes, he had an old laptop lying around from 2015, an old MacBook, and he ran like the TPCH dataset benchmark on it with 1 terabyte of data on like a 10-year-old machine. And that worked. That was quite funny to see. And that was something that people in the past have used, like easily have used distributed computing for.
Okay. And under the hood, I mean, you basically developed the system from scratch, right? So it uses, or you used C++ as far as I know, right? It's all written in C++.
Yeah.
What led to that decision? Like, just because you were used to it, or because like the performance is still crazy much better than if you would use, I don't know, Go or something trendy?
Yeah. I mean, the reason, so for us, C++ was actually modernizing, because it's funny, in the database world, everything was written in C for a long time. So the database system we were working on was written in C. And like all the other big database systems in the open source, like SQLite, MySQL, Postgres, they're all written in C as well. So for us, we were like, we're modern, we're using C++. Obviously, that's no longer true. We can't claim that it's modern anymore. But at the time, that was kind of the idea. Why did we use C++? I think performance is the biggest factor by far, together with our own expertise. Like, I mean, we were more C programmers than C++, but there's a lot of sort of skills that sort of transfer, because C++ is, I mean, it's kind of in the name. It's like C, and so like a lot of bells and whistles, but in its core, it does, like if you understand C, you understand C++ very fast as well.
Okay, understood. What else is under the hood? I mean, it seems to be like super small and super efficient. How did you get there? What else is there? Like what you really urgently depend on?
So do you mean in terms of like
libraries, technologies, like what's like
So
what's under the hood?
We actually have a very strict no external dependencies policy. So we don't really rely on many libraries. And that's one of the reasons we have this extension ecosystem, because the core of DuckDB is supposed to be completely standalone. That doesn't mean we don't use anybody's code. Like there are some dependencies there. So for example, one of the things we do is we have used the Postgres parser. We are actually in the process of replacing it with our own. So, but that's still like a work in process. We're still using the Postgres parser, and have for many years. It's great. Like it works. It does the trick. As for like the actual sort of core number crunching. That's all like we made it. We programmed it. Obviously, it's building on top of a lot of research in the database world, and sort of like the fundamentals of the system are very much based on the state of the art in sort of how do you build a fast analytical database system, which is research that has been also partially carried out at the research institute we came from. So we were very acquainted with the people that actually did that research, and like obviously the research field. Like there's a lot of amazing ideas in the database research field that for a long time had only been implemented in sort of the closed source, like high performance engines like Snowflake and BigQuery, and not in the open. And we have taken those ideas and pushed them all into the open source.
Yeah, super cool. A really exciting story. And I think many CTO listeners will ask themselves like, hey, how can I use it really for my production workloads? And then like quickly people shed a light on resilience. What like, I guess that's like just a mother duck use case, that like if one duck box dies, then there's replicas and there's like automatic restarting and auto scaling, etc. And that's for just not what you worry about, I guess.
We worry about resilience in a different way, not in terms of like if one dies, we restart it because we don't have a server, right? Like we don't take care of that for you. So you have to kind of figure that out yourself. Obviously, there are solutions that you may use elsewhere in your tech stack that work for this as well, like Kubernetes and things like that. But we do care a lot about stability of the system.
Okay. So your overall like one box resilience is super important, and you don't want your process to die and no core dumps, etc.
But it has to keep running. Okay. That's we have an internal motto, which is never give up, never surrender, from Galaxy Quest, if you've seen the movie. And the idea is that we should always keep running. Like we should never crash or run into out of memory exceptions, things like that. And then like as long as your machine still has resources available, that'll keep crunching. So that's also one of the things that we try, is that your RAM shouldn't be your bottleneck. It should be your hard disk and your disk space, so that if you run into a scenario where your query doesn't fit into RAM, the system will like spill out intermediates to disk and like gracefully degrade performance while still finishing, instead of like just popping up and saying like out of memory. And that's something that in a lot of cases we actually do a lot better on than Spark. Like there's queries that DuckDB can run that Spark can't run, because if Spark has to gather too much data onto a single machine, it will just die. Whereas we are much more like resilient in that regard.
Okay, cool. Super exciting story. I still have a little exciting surprise for you while slowly coming to the end. While like recently poking around the DuckDB CLI, I accidentally typed install Quark, load Quark.
Oh, yeah.
And then I don't know what led me to that, but I figured out that there's a .time machine feature in the Quark library. Like you can just use it and travel back in time physically. So imagine we now use that little feature to and I typed time machine 2012 and you now like can watch yourself back in the days nerding around 2012 on the CWI lab with the very first embedded analytics prototype, and you have 10 seconds to whisper something into young Mark's ears. What sentence would it be?
I think just keep doing what you're doing, because it's working out. Like I think so. There's many things that I could tell myself at that point, like many lessons learned. But I feel that in some sense, it's kind of crucial that you learn them yourself by like hitting your like head against the wall. Like many of the things that we did right in DuckDB, I think we did right because we did them wrong first in our like initial prototype. Like there was many sort of like things that we learned because we tried them with like MongoDB and it didn't work, and like people were complaining about it and that didn't work. And I think if you just tell yourself that, right, like, and you don't have the same sort of the lessons, the pain that comes along with that, then maybe it doesn't register in the same way, I feel.
So you actually needed the pain in your forehead because you smashed against the wall.
you need the head. Yeah, we call that the head bashing. You need some head bashing. Otherwise, it doesn't quite stick around.
What is your last head bashing moment?
It's usually CI related, like anything sort of build system, continuous integration, things like that. Those are the head bashing moments. So we call a head bashing moment like we whenever there's something that you know you're going to solve, but you need to just kind of like keep on like going through it, just do it. Like we call it the head bashing moments, and I think it's kind of critical to have those.
So, still little detour question, but I mean, you're quite low level, right? You develop C++, I guess, day to day.
Yeah.
And I would say you're like 99% geek or nerd. I don't know how you differentiate.
It's fair to say. I would say 100%, but I don't know where you got this 1% from. But.
How do you see AI development for your personal use cases? Like, do you use, I don't know, anything like Claude Code or stuff like that? And how excited are you about it? And yeah, how many problems does it solve for you? Honest answer.
So personally, I don't use this at all, but I think that's also because of the nature of like where I'm working. Like a lot of the stuff that I'm doing, it's very core, very low level, and the AI just it can't really help you there. Like there's very specific things I need to build and program that just haven't been done before that I feel doesn't really help you with. I think it does very much help if you're doing like higher level stuff. Like I think some use case where I've seen where you're like basically composing other libraries, things like that, like writing Python code that compose different libraries, I think then it can be very helpful. But for the sort of like low level C++ programming, I haven't really found it that useful in general.
Okay, yeah, that's just a survey. I tend to query again. Thanks a lot. Very, very nice talk, and really looking forward to the moment when I can like send my congrats whenever, like, I don't know, Google acquires you for 50 billion or something. let's wait for that. And really crazy what you've built there, and really, really fun to observe that. And let's see where the time takes you. Huh?
Well, thank you very much. Thank you for having me.
Thanks a lot. Have a great day. Bye.
Thank you.
Thank you for listening to the AlphaList podcast. If you liked this episode, share it with friends. I'm sure they love it too. Make sure to subscribe so you can hear deep insights into technical leadership and technology trends as they become available. Also, please tell us if there is a topic you would like to hear more about or a technical leader whose brain you would like us to pick. AlphaList is all about helping CTOs getting access to the insights they need to make the best decisions for their company. Please send us suggestions to cto@alphalist.com. Send me a message on LinkedIn or Twitter. After all, the more knowledge we bring to CTOs, the more growth we see in tech. Or, as we say on AlphaList, accumulated knowledge to accelerate growth. See you in the next episode.
Dieser Podcast wird produziert von Podstars bei OMR.